Hello everyone, my name is Joe Scorsone, channel is called Ethernet Wink, and in today's video we're going to be pricing options using the binomial pricing model. Why are we going to do that? Well, my option pricing videos tend to do better than other things, so I'm going to keep on making them. There's other pricing models out there besides the binomial. This one's a little chewy to understand. I don't want to really understand like the Henston model and like Poisson jumps. I get them, but I get Poisson jumps, but I think that it's misleading at best. Regardless, we're gonna get into this video, and if you guys want to see a video on that, I'll make it regardless. But binomial pricing model, right? So there's two kinds of options. There's European style options and American style options, and they're different. They're very different because European style options exist in the lifetime of the option, from inception to maturity, no questions asked. An American style option can be exercised at any point. So when a European option will be alive for this time, maybe an American option is alive for this time, left to right. But so now we have to model the price for each point in time. At each different price the stock could be, because you could exercise at any point in time. How do we accurately model what this contract should be worth, right? So let's get into the code. I have a sticky note. I have a sticky pad on my desk. Can't beat it. Can't beat it. I'm going to digress for a second. Can't beat a solid sticky note. Ow, I hurt my shoulder in the gym today. I slipped practicing my high kicks. Terrible. But can't beat a good sticky note and pen. Regardless, before we get into the code, we're going to talk about an Investopedia article. So we have our stock price and our current option price at inception today. And then in the future, stock can either go up or down. So now we have to calculate the option payoff, assuming the stock went up and assuming the stock went down. And then we figure out the options price from that payoff, from backward induction. I don't know if induction like gives you like makes you upset. Makes me a little upset. I remember like discrete math. Induction's not fun. Okay. Let's go from main and then go up into everything else. So we have the normal stuff that you think you would need to price an option. Current stock price, strike price, risk-free rate, time to maturity, volatility. Cool. So now, and then if it's a call or not. Now we have a few new things. We have the number of time steps, if it's an American option, and our dividend yield. That is high. That's higher. There we go. We're going to get into why I have dividend yield a little bit later on. We're going to play around with this. We're going to show how American options can differ. And then everything else is pretty much just calling the class. I did it all in the class this time instead of like a struct with a bunch of functions. I think in this way a bit more. I like Go. I like Golang, and Go doesn't have classes. It has structs with a bunch of functions. I don't know. If you ask me, this whole file is just one big class in my mind, because I have an object and I have functions to do stuff to that object with it. So that's a class. Whatever. I know that's an incredibly misleading way to say that to anybody new to computer science and to anybody. Let me talk freely. This is my YouTube channel. I'm going to say all the misleading programming information I want. Regardless, now we're going to get into our class and we're going to initialize everything. So I'm not going to go into the ins and outs of C++ too much either. But yeah, we're going to go over our private first. So we have all of our variables, and we have some new variables that we wouldn't have before. So let's calculate them. So dt, it's time over n. That represents this. dt is how much time is in this change right here. We have u, d, and p. U is how much the stock is projected to go up in 1 dt. And D is how much the stock is projected to go down. And you can see it's pretty much a function of, and this is risk-free rate, and dividend yield kind of get nullified. So it's pretty much a function of how big n is. Well, pretty much a function of just dt and sigma. So if you know a thing or two about pricing options and how volatility is calculated, you might be seeing dollar signs right now. I hope everybody gets that. You got to gatekeep a little bit of these things, just a little bit. You'll get it if you want to know what I'm talking about. What I mean when I say find an underpriced option, why you see dollar signs because of how we calculate sigma. Just dive into it a little bit, learn about what kind of data the stock market really is, and you'll get it. You'll get it. I want you to get it on your own. If I tell you right now what I mean, it won't hit you in the same way. You won't look at the world and be like, we've been doing it like this for so long. You won't do that, and you have to. Regardless, though, this is how much the stock is projected to go up and down for one DT. P is represents the probability pretty much. It's not an actual probability, but it's pretty much the chance of just the risk-free rate being the return. It's a risk-neutral probability. It is a probability. I don't know why I said it's not, but it's the probability of the stock moving up so that the discounted expected value of the options payoff matches its current price. That's a mouthful, but it's pretty much like the chance of from the option moving, we pretty much got the risk-free rate of return. Now we have to price the option for that, and then we just discount it to present value. I apologize if you can hear that engine outside. I don't even know what it was. That's it just really distracted me because I'm a nerd. I like pricing options, but I also like fast, loud things. So, and then this is just option payoff. So, like, let's say I have a call, strike is 101, the strike is 100, and the stock's at 101. My payoff is $1 share. Cool. Price is the only function that we got. So now let's get into this. It's a little chewy, a little counterintuitive because of how backwards it might seem at first. Literally, actually, we're going to get into that. But so we have a vector of option values. So now we're going to calculate the options value at maturity. Right? So now we're going to see how many steps we can take. And we're going to start at the end of it, right? We're going to start all the way in the future and then come down. So we're going to get the price at maturity, calculate the payoff of this option price at maturity, right? Because we get, actually, that's pretty much the stock price at whatever time, because then we're subtracting it from the strike price. So this is our simulated, that is this value right here. We're calculating the payoff of the option with that value, and we're appending it to our option values. Why are we starting with option values? Well, because of backward induction, right? Don't ask me to explain it a lot to you, but we're going to use backward induction. Pretty much the way I think about it, like what it's resembling, it's not like this. It's more complicated. If speed equals distance over time, if I give you time and speed, you can find distance, but present value is there, so that's why it's not exactly that, but regardless. We're going to go through, we're going to start at the end of all of our trees, and we're going to come forward. So now for every option value, every payoff we just calculated, we're going to, actually I should say here, like for these ones, we're going to find out what the price of that option would actually be, right? So we're going to use our P because we're going to model it with the price of it chance of this neutral risk-free return happening and then not happening, right? So we're going to use that as well because of how the time works, because we're using this in our calculation for this, right? That makes sense. So that's why we're also grabbing, because when we say +1, we're then like going into the future. Not into the future, but since we're starting at the end, we're technically going into the past. We're modeling what this number would be with this. Does that make sense? It's chewy. And then if it's an American option, then we're checking if there's an early exercise. So we're pretty much seeing how attractive it is. If the options payoff is more than what the options value would be, then we're appending that. We're pretty much appending whatever's bigger, the option's payoff or the option's present value. Okay, and we're returning the first one. So that is so chewy. That's a lot of information. And then we're pretty much just calling it, getting the American price, getting a European price. I think that the best way to really understand what this model is trying to do is to run the code. So if you this would be the command g++, whatever your option, whatever your C++ file name is, -o. I like to add out on it. Yes, I use Windows. At least I don't know. I don't have a joke. But yeah, let's compile this. I'm keeping it right here so that we can see at the money call 3% dividend yield. The price of these two options will not be very different. See, pretty much identical. That's because we don't have any real advantage here. Dividend yield is only 3%. Well, only 3%. It's pretty much normal. That's why it's more by a little bit. But we're out of the money, right? So even, let me increase this. Let me make it absurd. Just 15%. Oops, not ones. See, now it's way more actually. That changes the value of it a lot, like even just as a base. But you can see what I mean. So now, given that I can exercise this at any point in time, I don't have to wait until expiration. I could exercise this, collect this 15% dividend yield. This imaginary company I just made up. If it's 5%, which is actually 7, it's like a realistic high number. It's still different by 30 cents, which is still a lot. And so now let's put this back down to 3%, and then call option. Let's say it's $10 in the money. You'll also see how it changes here. Will you? Let me model that a little bit different because the dividend yield is the new addition. So yeah, here we go. Here we see the difference. I'm surprised. I just confused myself because I thought that, I think it just has to be more drastic. You know, truth, yeah. Not even actually, just a little bit. But yeah, truths lie in the extremes. Forgot where I heard that. But forgot if I believe it. But yeah. And the concept applies to puts as well. Right? Same idea. The distance, if we change this, that'll also change our values. So now if we change it just to 10, this will be an extreme change. Which way makes it way huger? Way huger, way bigger? Okay, I guess I forgot. I guess I lied because it's pretty much 60 cents in both of them. But yeah, I hope that you guys can understand how an American option is modeled differently, and also because if we were to say 3, I'm pretty sure it'll have a 3 in there. Yeah, because we're doing 100 steps, it'll definitely have a 3. And then we just model an at the money call just because why not? We could see actually what I'm going to do instead, so that way it's a better comparison. I'm going to type in clear, not whatever that was. Compile it, run it. See, that's our first value. And then if we try to use the third, here we can see how it changes as you go down the tree. Some cool changes that you can maybe make to this is to use more pointers when you return stuff. Could be to add a chain to it, like an actual options chain like I did in the other videos, and to actually print the entire tree like a tree. Some sort of front end could be cool, but yeah, that's pretty much all I got for you. This video was pretty much more focused on the differences between an American option than an European option, more so than the literal code for it. Went over a little bit how values are calculated, and the code will all be in the description. So like that U value, you know what I mean? How much the stock is expected to go up relative to its risk-free rate and dividend yield. And then you have the how big your time step is, and then sigma, right? That could be, I'll show you. Like this function could have useful things for anybody, for any sort of quant, you know what I mean? Could always be nice to have a value like you around, but pretty much just a better estimation of a risk-free rate and of sigma. But regardless, I hope that you guys enjoyed this video. I hope that you guys found some value in it. Um, please comment down below any other things that you want me to make a video on. That's the word for it. And yeah, I have a business. It's called Prometheus Analytics. I provide trading indicators for people on TradingView. We've actually been having an absolutely killer time with our indicator, with our reversals indicator. I made this totally original. You don't have to input any values for it. Just put it on your chart and play. Reversals right off the bottom, 2 days in a row. Of course, not every day is like that. See, we have this bearish alert right in the middle of nowhere. This one was meh. This one was meh. You know what I mean? But overall, we see some pretty cool alerts. We have some other indicators too. If you don't like that, you like price action, we got you covered. You like trading with ribbons, we got you covered. You like free stuff, this is free. Same idea as reversals. You don't need to input these values if you don't want to, but we give you the option. But yeah, link to that, link to my Twitter will all be in the description. One thing I want to talk about too is kind of like a thing to look out for is that a YouTuber with the handle of Coding Jesus, that's what he calls himself. I'm gonna call him CJ because I'm a Christian and that makes me a little uncomfortable to call him that. CJ made a video talking about, and I'm not knocking the guy at all. He's very smart, and I don't know if that was malicious or not, but weirds me out. He made a video talking about projects for quants and interns to make to impress an interviewer, and it was an order book snapshot idea in C++ with server side and clients and stuff like that. And I have an idea for it. I have an idea of how to make it different, how to make it my own, and I like coding in Golang because I like C++ and I like Python, and Go kind of, in my mind, Go puts the cool things about both of those together, besides pandas, but whatever. But yeah, I want to make a video adding some stuff to that, changing up the concepts in it, and because also Go has Go routines, it's different than, not necessarily different than async, but it's not an async function. The function becomes a Go routine. But yeah, do much of that stuff, so that's something to look out for as well. Links to socials, links to references, all of that will be in the description. Channel is called Ethernet Wink. My name is Joe Scorson. I will see you in the next one.